Today we're going to talk about absolute value functions. In prior years you learned about absolute value. The absolute value of a number is its distance from zero on the number line. So given a number line, the number -4 and the number 4 are both 4 units from zero. So this is how you indicate absolute value. It's these outside braces. So this would read the absolute value of -4 is equal to +4. The absolute value of 4 is equal to 4. Many of you in your prior years just remember that anything inside the absolute value symbol will always be a positive answer. So another example would be the absolute value of 5 would also be 5, and the absolute value of -5 would also be 5. These are both 5 units from zero. So now let's look at an absolute value function. First, an absolute value function is a function that contains an algebraic expression within absolute value symbols. So here's what one looks like. F of x equals the absolute value of x. Or you could replace y with f of x. You'd have y equals the absolute value of x. Now today we're going to look at the graphs. This table for this particular function would look like this. So we have the absolute value of -2 would be 2. The absolute value of -1 would be 1. The absolute value of 0 would be 0. The absolute value of 1 would be 1. And the absolute value of 2 would be 2. Your graph would look similar to a quadratic graph, except it comes to a point. So basically what you have here is you have a minimum and a vertex at the origin. Now let's look at transformations of absolute value functions. First off, a transformation of a function is when you move or resize a function based from changes made to the parent function. So let's talk about a parent function. A parent function is the simplest function of a family of functions that preserves the definition or shape of the entire family. So for absolute value, your parent function is going to be y equals the absolute value of x. This is the simplest form of this equation. Notice you'll have an absolute value shape of a v with its vertex at the origin. Now, if I were to take a number in front of the absolute value of x, and for instance put a negative, one of the transformations is a reflection. It's going to turn this graph upside down. So instead of opening upwards, this graph will now open downwards. But notice the vertex stays in the same spot. And just a reminder, these are similar to quadratic functions, which were parabolas. Absolute value functions have a vertex, which can either be a minimum, like these blue lines, or it could be a maximum, like this red line. Also, you can have axis of symmetry as well, similar to quadratics. Now let's look at the general form of an absolute value function. This is what an absolute value function looks like. The f of x equals some number a, absolute value x minus some number h, close the absolute value symbol, plus some number k. So let's break this down. The first part, a, if a is greater than 1, the graph is going to get narrower than the parent function. Obviously this would just be 1 if it was the parent function. If the number is between 0 and 1, well then your graph is going to become wider than the parent function. So to give you an example, the parent function is the blue dashed line in the middle. The red line is 3 absolute value of x. So basically multiplying by 3 here. Notice how the red graph gets narrower compared to the blue graph. We did not change the vertex, still the same point. Also, if you look at the green here, this is 0.5 absolute value of x, or 1/2, so it'd be between 0 and 1. And notice the parent function is in blue. Your green is now going to be wider, same vertex, but a wider opening. All 3 of these open upward. If we had added a negative into the a, so if it was, for instance, -3x, it would get narrower but also flip upside down. So it would look something down here. Okay, next we're going to look at what happens inside the absolute value. We talked about a. Now, inside the absolute value, you're either going to subtract or add some number h. So what happens is if you're adding a plus h, it's going to shift that graph h units left. If you're subtracting h, it's going to shift h units right. So let's look at an example. The black line in the middle, the absolute value function here, is your parent function. This is the absolute value of x plus 2. Notice it shifted 2 units left the entire graph. Over here, if we subtract 2 inside the absolute value, it's going to shift your graph 2 units to the right. Same exact graph, just move 2 units to the right or left. If this had been, for instance, x minus 4, well then you would move right 4 units from the origin. You always go back to the parent function. Now let's look at this outside the absolute value. If they add or subtract a value outside the absolute value, your graph is going to shift up and down. So for instance, if they add some number k, it's going to shift that graph k units up. If you subtract k, it's going to shift k units down. So in a graph, the black absolute value is your parent function, y equals the absolute value of x. Here would be the absolute value of x. Notice the plus 2 is outside of the absolute value braces. So this moves the whole graph up 1, 2 units. If I were to do subtract 2, notice again outside, you're going to move down 2 units. So there's a big difference between adding inside. If you add inside, your graph is going to move right or left. If you add or subtract outside, you're going to move up and down. So now let's look at some examples. Question 1. Write an equation that would represent an absolute value parent function that has been shifted 1 unit left and 3 units down. So first let's look at the general formula. F of x equals a, absolute value x minus h, absolute value symbol plus k. We don't care about a in this case. They're not multiplying anything outside the absolute value. But the shifted left is going to focus on our h part. So if I'm going to shift left, that means that I'm going to have to do x plus 1. If you look back at the previous slide, if I were to add a number here, it moves the graph left. If I subtract a number here, it moves the graph right. Now, to move something 3 units down, outside the absolute value, you're going to subtract 3. So your final answer would be f of x equals the absolute value of x plus 1 minus 3. This says to shift 1 unit left, 3 units down. Let's look at the next graph. James graphs the equation y equals a, absolute value of x. If Lauren multiplies a by -2, describe how the graph would be transformed. So James would write y equals a, absolute value of x, and Lauren would write y equals -2 times a, absolute value of x. So you need to think about, what does this -2 being multiplied by a, how does it affect our graph? For starters, this could be the parent function, it could be any function, but you want to focus first on the fact that they multiplied by a negative. The negative here is going to mean that whatever graph we have, which originally would open upwards because it's positive, is now going to open downward. So for the first part, the graph would flip upside down. It's going to open downward because of the negative. Next, we're multiplying by a 2, which is greater than 1, so therefore your graph is going to become narrower because it's multiplied by a number greater than 1. So the red here deals with the negative, the blue here deals with the 2. So again, flips upside down for the negative, and gets narrower for the 2. Now let's look at question 3. What is the vertex of the function f of x equals the absolute value of x plus 1 minus 2? First, let's look at the graph of a parent function. Here's the parent function. You can see, because it's the absolute value, that has a vertex at 0, 0. So for starters, the parent function has a vertex at 0, 0. Now you have to look at this particular problem and figure out, where would this parent function move on the graph? So for starters, it's not going to flip upside down, it's not going to get narrower, it's not going to get wider. There's nothing in front of this. For starters here, you're going to have a plus 1. If it's inside the absolute value, you're either going to move left or right. So for adding 1, that means we're going to move left 1 unit. So my vertex here would be 0, 0, would move here. Now the next part of the problem is we're going to look at the minus 2. If you're subtracting 2 outside the absolute value symbol, this graph is either going to move up or down. So here we already moved left 1 unit. This is going to say now to go 2 units down. So we went 1 left, 2 down. Your new vertex would be at -1, -2. So your graph would look something like this. -1, -2, and break. So the new function will be shifted 1 unit left and 2 units down. The new vertex would be at -1, -2. So you actually don't need to graph these. You can just use your information on transformations on where the graph is going to move. Just always compare it to the parent function, which is at 0, 0. Hope this helps. See you guys soon.